Just curious, how many folks went off and set up shop last week after the lecture? Nobody started their companies yet? Come on. Come on. All right, by Friday, I'm expecting everyone. Incorporated, LLCs, sole proprietorships, whatever it is. Okay. So announcements. I don't know. I didn't really have any today, so unless you have some questions of any.
Having a LAN party on Friday.
CS Club is having a LAN party on Friday. All right. So, yeah, what's going on at the LAN party?
You bring your computer and play video games on the local internet with like-minded folks.
All right. So Friday, where?
Kemper 1131.
Kemper 1131. All right. So bring your crazy PCs and and have fun. All right. In terms of questions, somebody on the news group asked, and I did not respond. The question was something about what code can we use. So for me, I don't really care. Like, use anything that you possibly can, because I just want to see. I want to see something shipped. Now, I'm not saying like, rip people's code off or anything. Look at the licensing, and if you're planning on doing something that's going to be a commercial product, be aware of what sorts of license the code you're using has, and give credit where credit is due. And at the end of the day, it's about getting stuff done, and understand whatever code it is that you're using. So, any questions about that? Is everyone familiar with LGPL, GPL, FreeBSD, MIT license, any of that sort of stuff? Well, if you come across some code, take a look. In a nutshell, if something is GPL'd, then the idea is that if you utilize that code, then you must make your code open source as well. That's sort of the general gist of it. Usually what happens is, if you want to make something closed source, you can contact the folks that wrote the software that you're interested in, and oftentimes they'll offer you a different license at some sort of a fee, which is fine. If you're going to be piggybacking off all their work, then it makes sense to pay them. The other one, LGPL, is very similar. So for anyone who's using Cocos 2D is using an LGPL license, but then they also have like a little exception to it. But the idea with LGPL is if you're going to use a library, so that's usually when LGPL applies, as far as the iPhone is concerned and say Cocos, if you use the LGPL stuff, if you make modifications to the library, then they ask that you return, you essentially open source and return those modifications to the community, but they don't require you to open source your code that's linked against this library. And then MIT and FreeBSD, they're much more open. It's more about just saying, okay, well, here's, I'm using this code and here's the license, and it's basically you try to do something where you're not trying to take credit for stuff that you didn't do. So you just, So take a look at that if you end up using other people's code, and don't be afraid to give people acknowledgments, because there's nothing wrong with that. Any other things before we jump in? Concerns? Everyone doing okay? We've got the next milestone on Friday. All right. Well, I guess this is where I get to sit down. So today we've got a number of little topics to go through. We're going to talk about object archiving, property lists, briefly user defaults, and the iPhone file system. So all this stuff we're going to talk about. I don't plan on taking too long unless questions sort of come up. Some of these things, I have a basic knowledge of, just because I'm kind of familiar with the stuff. Some of these things I've used. Some of them most of these things I guess I've used, except object archiving we've all used actually indirectly. I haven't used it personally for any of my projects directly, but let's take a look. So object archiving. So the idea, and we've seen this with Interface Builder, so the idea is you have some sort of system or some sort of graph or object hierarchy, and you want to persist or save off that hierarchy of information for later use. So with the archiving stuff that Cocoa provides, basically what you can do is you can take, say, some object or group of objects and grab their information and put them out into a file, and then at some point later you can read that back in and basically reconstruct the state of your program. So it's sort of like it's this freeze-dried, you have these objects and you freeze-dry them, and then later on you sort of defrost them and make use of them. So again, we've seen this with Interface Builder where we're fiddling around in Interface Builder, we save something off, and they're saved off as these zip or these XIB files, which generally we just call nibs, which is basically is the representation of that object and whatever connections it has. So, if you want to do some object archiving stuff, then basically what you need to do is you need to adopt the NS coding protocol and implement these two methods. The first one is init with coder, which again we've seen. I think there was at least one example I did when we were talking about, well, here's how to do this stuff in code. And we were walking through, and when a nib file was loaded, so when nib files get loaded, init with coder ends up getting called. So if you want to make modifications or additional, do additional sorts of modifications and settings, you could do it in init with coder. Encode with So encode with coder, basically, sort of descriptive. So you encode the object in some way. So hopefully, I don't know if this is, I may have made this a little too small. But so in terms of object encoding, basically, so you implement encode with coder, and you give your parent class a chance to do whatever it needs to do. And then you call, basically you call these encode whatever methods on the coder. So encode object, map name for key. So it's you give it your object and some sort of name for it. Encode float magnification for key, MV magnification. So nothing too fancy. It's just you say encode, you give it an object, you give it a name. And in terms of decoding, it's pretty much the same thing except in the other direction. Now, instead of encoding, we're asking the coder to decode the object for some particular key. And if you notice these, the decode things, they have these retains because, we don't see any of our narc words in there, so new, alloc, retain. Well, we're putting retains in there, but we don't see any of those inside the method calls. So if you want to hold on to whatever you're decoding, you need to retain it. So to actually create the archive, so how badly, can you see it back there, anyone? Barely? All right, sorry about that. Let's see. How's that?
That's great.
All right. Power of technology. So in order to actually archive an object, basically, you need some path to the file. So we'll start at the top. So we've got this assume this exists, this MyMap view. And we have a path to the archive. And we'll see, so NS temporary directory returns you, and we'll look at the file structure of stuff in a little while, but basically you get a path to the temporary directory of the application, and you say that, we want to call the archive map.archive, and then you use this NS keyed archiver and give it your object, MyMap view, and give it the file path. And basically, when you do this, it's going to go through and call the encoder and basically gather everything it needs to gather and shove it into that file. So to decode it, basically, it's going to be pretty much the same thing, except now we're asking this NS-keyed unarchiver to unarchive our object with some particular file. So far in the projects I've worked on, I haven't had to use any of this stuff directly. Maybe it's just because I'm not as familiar with it, but I haven't, that's just me. Maybe you'll find a good use for it in some of the stuff you're doing. So, if this looks like something you plan or that will be useful for what you're doing, so you want to save the state of your application in this freeze-dried form and kind of bring it back at some point, then take a look at the archiving guide, and you'll see seem pretty straightforward, right? You just have some encoders, some decoders, but of course, the devil's in the details. So take a look at this guide and look at the details. So next up are property lists. So the archive, like the NS coder stuff, is very general. Applies to these general graph structures and data structures. Property lists are a bit simpler in terms of it does something similar, but it works on some simpler data structures. So basically, property lists, they're a simple way to store data. You can store this data either as XML or binary, and you generally don't want to use property lists with huge amounts of data. So you want to keep your data 200 to 300K in size, and the main reason is that when you open a property list, basically it all comes into memory. So if you have like a 10 megabyte property list, you're bringing that in, and you want to make one little change. You don't have this. You have to basically bring everything in, make that change, and then put it back out to disk. Again, probably too small. So with property lists, usually, they apply only to certain types of data. So arrays, dictionaries, strings, integers, booleans. So they'll apply to NS arrays, NS dictionary, NS string. And if you look at the far right, you'll see there's some sort of XML element representation of it. And also so what's listed here is, say, NS array, NS dictionary. This also applies to the mutable versions, so NS mutable array, NS mutable dictionary. So what happens, so when you have a property list, if you're inside Xcode and click on it, you'll get this little editor that comes up. So it's this plist editor, property list editor, and you can see basically how things are set up. So you have this root, which is of type dictionary, and it says that there are 2 items in there. And if we look below, our first item is name, and it's a string, and the value is John Doe. And we have this array phones with 2 items. The first one is a string with that phone number. The other one is another string as well. So if you actually look at the file, the plist file, you'll see that it's an XML file in this case. So of course you can either have it as XML or as binary. In this case, this one's XML, so we can see. So we have that. If we look up above, there was a dictionary, and it had a key that was called name, and that mapped to this string that was John Doe. And then there was another key, phones, that had the array with the 2 strings in it. So property lists, it's a nice way of storing small amounts of data, and I'm trying to think some of the things I've used them for are just like application settings. So when an application starts, maybe there's like, for whatever reason, that's where we wanted to put little customization things. So you could control the color of various things by setting some properties inside this thing. So when the application launched, it would just look in the property list file and use that stuff. Yes?
A dictionary is just a set of key value pairs. Is that the basic idea?
So a dictionary is a hash table.
Okay.
So key value mapping. Yeah. And then there's so there's NS dictionary. There's also NS set. So the right. So the NS set. Well, I'll let you take a look. Basically, you have a bunch of, I guess we didn't go through a lot of the collections stuff that we have available to us in Cocoa, but you have NS sets, dictionaries. So usually set is something where the key and the value is the same thing, whereas a dictionary, you have a key and a value pair. NS, we've got arrays. And usually all of these have a counterpart, which is the mutable. So, for performance reasons, you might want a data structure that has a fixed size so it doesn't change, but for flexibility and for whatever it is you're doing, it might be important to have a mutable version, so those are there as well. And the place to look to get a good look at that is the collections programming topics. And you can get all sorts of info on all the various sorts of things in there. There they go, all the ones we've got. So in terms of actually, using a property list, basically, so if you have stuff in an NS dictionary or an NS array, and that's the stuff you want to save off, well, basically you can just, send it the write to file message. And in this case, it's write to file atomically, where basically the atomically, I believe, if you say write the file atomically yes, then I think what it'll do is it'll write the data to a file first, make sure that that's, that actually happens, and then it will replace the file that you want to write with the stuff that was atomically written. And it's sort of this thing where if your application crashes or it's interrupted for some reason, you don't want to corrupt the data that was there before while you were trying to write. So there's some other one. There's also write to URL, but I just kind of put this one up to see. And then there's sort of the corresponding reading property list. So if you know that the stuff in your P list basically is just going to go into an NS dictionary or an NS array, you can do the same thing where now you can initialize your array by with the contents of some file at some path. And of course, I think there are some convenience methods. I don't know what came over me. Usually I'm pretty good about having big stuff. But so, we have these convenience methods. So instead of using that init with contents of file, you can say, NS array with contents of file, or NS mutable array with contents of file to bring that stuff in. So, sometimes things get a little more interesting, and you want to have more control over the properties of these P lists than what some of those other methods on the collections provide you. So, for example, maybe you want to store the data in a binary format instead of an XML format. You would need to go something more this route, which basically. So first line here is just creating a path to, this data.plist file. And then we're creating this NS dictionary. with some objects where yeah, we're just creating this NS dictionary with some stuff, and the magic thing here is this NS property list serialization, data from property list plist data or plist dict, and then the format. In this case, we told it that we wanted to use this XML version 1 format, and then if there's some sort of error, we want to put it in this error variable. And so doing that returns you this NS data thing where basically you can take that and say, okay, write this data to a file. So again, it's pretty straightforward stuff with these things. Again, if property lists are something you think you're going to be using, then check out the programming list programming guide or the property list programming guide just to get more information and details on it. There are plenty of examples, and actually a lot of the things from in here I pulled out of this guide, so take a look. So next up, very briefly, we'll look at user defaults. So there are times where you want to remember that the user flipped some sort of switch or set some sort of setting or did something in particular. What you can do is you can use NS user defaults to save that information. And actually, NS user defaults, I think, is implemented using plists. But so yeah, basically you can use it to save the users some preferences or say some sort of navigation state. So they've gone to some particular screen and they quit your application, and for whatever reason it seems like the right thing to do when they relaunch the application is to come back to the screen where they left off. You could store that info in this using NS user defaults. What you don't want to do is you don't want to store giant objects or images inside this NS user defaults, and you don't want to use secure information. You don't want to put inside of here because it's not encrypted in any way. And basically the place for this, look up NS user defaults and you'll see a few samples like this drill down and save. It shows you how to go to some particular screen and quit the application and relaunch the application, and it starts you on the screen that you left off at. All right. So any questions so far? Okay. So let's take a look at the iPhone file system, which basically is very similar to what you have on your desktops or your laptops on OS X, except it's sort of, it's this sandbox environment where they've done some things to make sure that you don't mess up other applications by writing into their little sandboxes. So you're contained in this little world, and you're limited to writing to a few places. There are some exceptions to this where there are some through some system calls you can get to the address book, or you can get to the user's music or the photo library, and you can do some things with that. But in general, your application is limited to its own little world, which I think if we take a look, so if you go to your home directory, library, application support, iPhone simulator, user, applications, basically you'll end up in this directory here, where this is the simulator's path to where all the applications are stored. So you can see I've got lots of applications on my simulator for various reasons, and you'll see all these weird names. It's basically just some random information that's created to to name the application. So if we actually look inside one of these directories, we'll see the structure of your iPhone app, or what it would appear like on the iPhone as well. So basically we see that in this case, this is the actual application, table view test. And I've got a documents directory, a library which has caches and preferences, nothing in there. There's some preference there, which if we take a look, we see our, some XML. And so all of the applications should basically have this structure. So let's see. Turns out that this, so the documents directory is a very important directory, because if your application needs to save data, this is generally where you're going to do it. So by saying save data, I also mean if your user syncs to iTunes or syncs their iPhone, stuff in the documents directory will be synced as well. Things, so I don't think, you won't generally be writing directly to, say, the preferences directory, but things inside there will get saved as well. Caches is a directory where, this one's very important. So say you have an application that for whatever reason, maybe over time it just downloads tons of little thumbnails just to try to make things faster for the user. But it's stuff that basically you can rebuild at any point in time should it disappear. So what you want to do is you'd want to put it in this caches directory. And so say another thing is, maybe you have a game that you're writing, and for whatever reason you need to generate a bunch of procedural content, or you have some sort of compressed stuff, and the first thing you do the first time you run it is you need to decompress a bunch of things. You can put it in this caches directory, and it'll make your users' syncing experience much more pleasant than the usual thing of kind of waiting around forever and ever while stuff syncs. And then the temp directory is basically a place where you can just kind of put stuff, but I don't know if the system goes and removes it. It's I think it can at any point. If it feels like it needs space, it will clear that out. But basically, you don't want anything that is meant to stick around between application launches. You don't want to put that into temp. So it's just sort of temporary stuff. Temp. So important directories. So we talked about documents. So this is the place where you would write whatever information you want to write and keep around and sync. Library, this preferences place. If you use NSUser defaults, it'll end up writing stuff in there. Generally, you're not going to mess with things in there directly. And then caches, that's where you want to put stuff that is important for your application to use, but it's not the end of the world if it goes away, because you can regenerate it. And you want to make your user's life a little easier by making their syncing experience as pleasant and fast as possible. So these directories, they have constants associated with them. So that document directory, you can refer to it as NS document directory. The caches one, NS caches directory. And we'll see at the end, there's a document, of course, that you can look at that shows you more information about all this stuff. In terms of reading and writing files, so you have the foundation framework where you can use property lists, which we talked about. You can do the archiving stuff that uses this NS coding protocol that we talked about. There's also NS File Manager, which lets you manipulate files, so create them, destroy them. And then there's NS File Handle, which will let you do random access into some file. What you can do is, if you want to go even lower level, you can use the Core OS. So fopen, fread, fwrite, that might look familiar from your days of C. So that stuff is available to you as well. So the place to look for more information on that is the iPhone Application Programming Guide, and particularly the Files and Networking section. And you can look at more about that stuff. So that's, as far as what I wanted to talk about today, that's it. Go off and write your applications and show me good stuff on Friday. If folks are looking for more books and things to sort of read, I mentioned some last time. This is another one I highly recommend. It's called Free, The Future of a Radical Price. It just talks about free stuff and sort of how a lot of what we're doing is, or using, is free. So take a look. All right, so any questions? Yes?
Is there a central place where you can start posting all of your keynotes so we can look over them later?
Yes, there is.
Whether that's on the news group or the website that
Yeah, so the website, I lost access to it, and now I've regained access to it. So yes, definitely I need to put all that stuff up because I've gotten behind on it because of various things. So yes, that will be up, and actually tonight I will either have them up on the news group or on the website. And I think there were some questions I saw about tab bar controllers. Andrew, who's Andrew? Is Andrew in here? I think that was the person that asked. Okay, well, I guess. So there were some questions about, manipulating data. How do I pass data around between my different controllers? So I guess the general comment that I'm going to make is that, your applications are set up as model, view, controller, and the controller mediates the interaction between your models and your views. So basically, whenever you need data in one particular place, you're sort of transitioning from one place to another, and as you transition, that's sort of the point where you can hand off this data. So if anyone has more questions about that, we can talk about it. Otherwise, I'm done for today, and I will see you on Friday. All right.